Open eScript Studio and create a new project by clicking on this file icon. Then select New, then select Renesas C++, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on this next button. Here select FPB-RA0E1 board from this drop down menu. After selection, click on this next button. Here select executable and no RTOS option. Then click on next. Here select bare metal minimal and click on finish button. Here click on open perspective button. IDE will take some time to open your newly created project. By default, IDE will open FSP configuration file. Here click on stack tab, then click on new stack, then click on connectivity, then click on I2C slave stack. Click on I2C slave stack, then open properties window. Here you can select pins according to your preference. After pin selection, we don't need to change anything here. Click on generate project contents. Then click on proceed button. Open HAL-entry.c file. In Project Explorer tab, expand Developer Assistant tab, then expand I2C slave stack. Here you can find different API calls related to I2C slave stack. From this drop-down menu, drag and drop callback function in your HAL-entry.c file. Then drag and drop I2C open function call in your HAL-entry.c file. After that, declare FSP error variable to check the status of API call related to I2C slave stack. Use assert function to make sure API call was successful. In FSP documentation, you can study example callback function for I2C slave stack. Every stack has this information icon. You can press this to open documentation related to this stack. Scroll down to find example related to callback implementation of I2C slave stack. You can copy this implementation in your HAL-entry.c file. Modify callback function according to your project requirement. Remove these read and write API call from your project. Then drag and drop read and write function call from Developer Assistant tab in callback function to read and send data to master device. After that, in global space, declare some variable to read and write data from master device. In read function call, you need to specify destination buffer for the incoming data. Also specify the size of destination buffer. In write function call, we need to specify address and size of the data which will be sent to master device. I have another demo project. In this demo project, I am making EK RA6 M5 board as I2C master device which will send data to RA0 E1 board. I2C master will send these 3 bytes to I2C slave device. Now click on your project name, then click on this hammer icon to build your project. After a successful build, right click on your project name, then select debug as, then select Renesas GDB hardware debugging. RA0E1 and EK-RA6 M5 device are connected with my laptop. I need to select RA0E1 device. Click on switch button to open debug perspective. In debug mode, open expressions window. Here you can see the real-time update of any variable in your program. As I am only receiving first 3 bytes from I2C master device, here I will inspect first 3 bytes which are received by using I2C slave read API call. Now right click on each expression name, then select enable real-time update. Here now we can observe when data is received from master device. After that, click on this resume button twice. Currently master device is powered off. When I turn on master device, you can observe the real-time change of these variables. Expression window is showing these variables in decimal system. You can verify these values by using programmer's calculator. Master device is sending 50 in hexadecimal system which is equal to 80 in decimal system. 92 in decimal system is equal to 5C in hexadecimal system which is second byte from master, and 93 is equal to 5D.